Our product is called the Ovenger, which is an automated oven designed to help combat the ergonomic issues associated with using a regular oven. Using a regular oven can be very difficult for the user to bend over while placing and lifting dishes into and out of the oven. These tasks can be especially difficult and dangerous for older or disabled people. This product is targeted for every type of person, but especially for those users who are older or disabled.
My back!
Have no fear, the Ovengers are here!
So, before we begin, does anybody want to see how this works?
The Ovenger incorporates a sleek, intuitive design with rounded edges and clearly marked controls. On the front panel, there's an open and close button that are used to raise and lower the rack, as well as opening and closing the oven door. For safety, a loud beep is played upon opening and closing, while the action is delayed, allowing users to move out of the way. Sensors on the front of the oven will not allow the rack to extend if there is an obstruction. To prevent burns in the event of a user circumventing these safety features, the arms and edges of the rack are coated in a heat-resistant layer to reduce heat conductance in the case of accidental contact. The inner workings of the oven itself are composed of stainless steel in order to be heat-resistant while still maintaining a lightweight design. Accidental fires are a known risk among kitchen ovens. If the Ovenger is heating while empty for more than 30 minutes, sensors inside will turn it off automatically. This safety shutoff feature allows the risk of fire to be all but eliminated during normal use. To address ergonomic concerns, the arm mechanisms of the Ovenger incorporate an axle-mounted L-shaped arm. The rack height is adjustable, depending on the length of the button press. This increased level of adjustability helps prevent injuries as it allows for slower and deliberate movement of the rack, giving the user total control over its location. For maximum visibility, the open and close buttons are color-coded green and red, respectively. The two buttons are marked open and close on the front as well to decrease any risk of confusion.
We wanted to compare the Ovenger to its competitors, so we designed an experiment. We gathered 100 random people of different ages and anthropometries to participate in our study. The experiment consisted of each participant carrying food from a standard counter and placing it in a standard oven 12 times. The participants would then repeat the task with the Ovenger in place of the standard oven. After each oven, the participants had to record any aches or pains they had, specifically back pain, and rate them on a scale of 1 to 10. We found that almost all of the participants had significantly less back pain after using the Ovenger compared to the standard oven, thus proving the Ovenger reduces back pain from cooking.
With the push of a button,
You can end back pain from cooking forever.
Despite there being an abundance of companies in the kitchen appliance industry, there are no other automated ovens that do not require users to bend down and manually transport food into or out of the oven. And with more and more people turning to home cooking, there are more and more people putting unnecessary strain on their backs by bending and reaching into their ovens. For these reasons, it was our goal to manufacture and introduce an oven that could mitigate this risk of injury. Other ovens on the market retail, on average, between $400 and $3,000 and are usually between 4.8 and 5.9 cubic feet in volume. While the Ovenger is similar in terms of volume, it would be more expensive due to the automated features that are included. However, it is anticipated that these costs will not overly hinder sales due to the human factors benefits, such as reducing the strain and risk of injury on users' backs. The Ovenger reduces these stress-related injuries by eliminating most of the bending motion from the oven use entirely. In other words, the improved human factors issues should increase the marketability enough to offset the increased cost.
The rotating tray of the Ovenger will be manufactured as a sub-assembly that is then attached to the main body of the oven near the end of the manufacturing process. The main focus in the added manufacturability and design costs is the added material cost for the arms, which have an overall added volume of 118.2 cubic inches. This added volume is made of the arms and the axle, which are both taken into account, with volumes of 81.38 cubic inches and 36.82 cubic inches respectively. This addition to the traditional oven found in homes across the country will result in a $17.78 increase in material cost. Estimated dollars per pound is $1.54. Using a density conversion to find the weight of the added parts allows us to find the added manufacturing cost, which turns out to be $17.78 as aforementioned. In addition to these added material costs, there will also be labor costs, as well as costs that are inherent to designing an oven with more sophisticated hardware. In terms of the actual hardware of the Ovenger, all of the capabilities that we are adding are already in place on a conventional oven, so an experienced IT person should be able to execute these changes with minimal costs added. Similarly, the added labor costs of manufacturing the Ovenger are expected to be minimal. The only added manufacturing includes manufacturing of 2 small parts with little complexity. The cost to manufacture these parts in an already large manufacturing plant should be minimal, operating under the assumption that machining is available for this manufacturing process, as well as downtime on a machine that is already in-house will be available as well.